First at ITSEC, a military simulation show that I was at down in Florida, and I saw an Oculus on the table and just kind of wandered up, and it turns out they're from Boston. So I said, hey, you got to come to our meetup and show us what you're all about. So we have here Mark Mento and Lisa Richardson, and they're going to tell us all about their eye tracking upgrade for the DK2. So welcome, SensoMotoric.
But before I start, just a quick show of hands. Who has experience with eye tracking equipment? Okay, a couple. The rest of you, I can pretty much say anything I want. You'll have no idea if I'm right or not. I represent SMI, and we're a company that that does all things eye tracking. And to give you sort of a quick view of what we do, we're about 24, 25 years old. Founded out of the Free University of Berlin, and with a satellite or a subsidiary here in Boston that's just about the same age. 90 employees. We're one of the larger, one of the more comprehensive eye tracking companies out there. It's not saying a lot. It's sort of a niche industry so far. But one thing that I think characterizes us a little bit is that we're very comprehensive in our approach. We do everything eye tracking. Now, eye tracking is a definition. What is eye tracking? If you permit me a really gross generalization that would annoy a lot of our customers, eye tracking is the process of measuring attention or perception or eye movements in response to visual stimuli or in the completion of a task. So the very simple, even more generalized definition is where someone looks and when they're either viewing content or when they're interacting with something or they're controlling their environment or they're doing a complex sort of multimodal task. Now, the practical application of that, here's some of the fields, or many of the fields that eye tracking is sort of in. You could read this as a basic list, but it's sort of progressing from the very basic research topics, which are also the earliest research topics, into the more applied ones, which are more recent. So originally, and we followed this progression. Originally, this was very much a clinical medical tool. It was in neuroscience research or physiology research or primates or things like that. We've sort of followed as it's become increasingly applied. It's gotten into psychology and understanding human behavior, developmental psych, then into things like autism research or Alzheimer's or dementia, and then finally into things like human factors research, user experience, marketing, and then at the very tip of this is human-computer interaction, and that last part is where we start to see the beginnings of something like a consumer approach to eye tracking. So this is where you see like assistive technology for disabled people. I don't know if many of you may have encountered that at some point, but if you have ALS or a spinal cord injury or something like that, one of the ways you can control a computer is just with eye movements. Of course, it's an extreme case because you've eliminated all the other ways of communicating with a computer, but that's where this starts to break into the real world. And we've also had some pioneering ideas in gaming and just general computer use that are, maybe the tip of something more like a consumer product. Now that progression, this sort of happened, this sort of progression in really applied stuff, in some sense this is how a lot of technology works, where the discoveries in the very basic area sort of feed the actual applications of the technology. In the case of eye tracking, it's also very much the progression of the technology in terms of usability. So in the old days, to use an eye tracker was to have to bite a bite bar or have a chin rest or something on your head to hold your head still or all kinds of other uncomfortable things. Now, for most of our systems, you don't touch the participant at all. Even when we do touch the participant, it's as simple as just wearing a pair of glasses. Right. Now, another sort of gross generalization, but eye tracking traditionally fits into 3 categories, or up until the thing I'm going to talk to you about today has basically fit into 3 categories. Basically, they're head-fixed systems, meaning that the person's head has to be stabilized in order to use the eye tracker. Remote systems, where that's not the case, the person can be more or less free. And head-mounted, where the person actually wears the eye tracker, right? So that first category, the one that would probably interest all of you the least, is chin rest, fMRI-compatible systems, animal-based systems, systems where there's ultra-high fidelity data, but the compromises in terms of what the person has to do to use the eye tracker kind of excluded from anything like a mass market application or anything in virtual reality, anything like that. So let's skip that category. Remote systems, for the past 4 or 5 years, have sort of been the standard for eye tracking. So this is a system where there's a camera somewhere, right, not touching the participant. They can more or less act normally within the space of the camera view. But then the system tracks where they look in response to some sort of visual stimuli. So in this case, it's sort of a typical developmental psychology research project. The child is watching something on screen, and the system is recording where they look. This also is the assistive technology, fits in this category. A lot of the early experiments with gaming fit here. There are a number of potential mass market applications, very specifically in this genre. But there are a couple of restrictions too. So you can't leave that camera view. The thing you're looking at has to be fixed in space. The third category, and in a lot of ways the newest, head-mounted eye tracking sort of gets around that. So this is a glasses-based system where you're not fixed in space. You can drive a car or walk around or handle objects. This has become the most common system in our portfolio in the past year or so because, especially in research applications, a lot of things have moved beyond just simulating it on a screen. So imagine you're an autism researcher and you're trying to understand social cues. It's one thing to show someone a picture of faces with different amounts of emotional content. It's another thing to put a system like this on and put them in a crowd and actually have a conversation, or maybe handle an object, or do sports training, or driving research, or flight simulators. To give you a very quick view of how this works, this is our glasses-based system. I put it on. It's self-calibrating and all that stuff, but that ball that you see there is my point of gaze. Right? So as I look around, you see where I'm looking. Right? Now, there's a lot more to it than just this. This actually sort of represents the real-time monitoring part of this, where you're just making sure that the person is actually doing what you expected them to do and all that stuff. There's a big data handling part of this that comes later, but you get the general concept. Right? Now, the downside of that approach, of a glasses-based approach, is both for researchers and for, let's say, professional practitioners of eye tracking, it's a little bit chaotic, right? So if I'm a market researcher and I want to understand where people look on store shelves, I can put the pair of glasses on and give them a shopping lift and send them to a store, but I'm not really in control of that, right? It's not like I've created stimulus or I've created an environment that I control. It's much more sort of open. That's its strength and its weakness. The next category, which I think we're sort of pioneering now, is to take that general real-world concept and apply it to a virtual real world, or at least an augmented one. Right? We've done this in a number of cases so far, both with augmented reality and virtual reality, but the Oculus adaptation represents our first actual product, the first thing that somebody can actually buy in this space. So the question is, who's it for? So the first category is not so different from our normal core business. So this can be researchers in psychology or human factors or cognition. It can also be professional companies that want to understand interfacing with a cockpit or a car or some sort of environment, but rather than doing it in the real world or simulating on a screen, they want to do it in a virtual reality space. There's also some clinical psychology applications and some autism and things like that. The second category, which I think might interest you a little bit more, is more the application developer and service provider category. So take my marketing example. If you want to understand where somebody looks on store shelves, now you can make a virtual shopping environment, right? and maybe you sell that as a service to big companies out there. You can say, okay, look, we can create a virtual shopping experience. We can control everything. We can toggle the placement of a product on a shelf, or the layout of the store, or the signs, or everything, and understand that from an analytical standpoint. It also has some applications in medical screening. Let's say you could screen for an ophthalmology or a vision problem, or a learning disability, or something like that. And then finally, there's the potential for mass market applications in that space. I don't know if any of you played Elite Dangerous on the Oculus. Do you know this game? Okay, so those of you who played it, it's like a space combat flight simulator that works really well on the Oculus. It's actually pretty amazing if you get the chance. But one thing that's awkward in that game, or at least from my perspective, is interacting with like in-game menus and stuff. Flying, I use flight stick and all that stuff. That's easy. But when you have a whole menu of things and you're groping for your mouse with the VR on, it'd be kind of cool if you could just look at a menu choice and press a button and select that thing, right? So I think we're kind of early in that process, but not. Maybe it's something that might not be that far off. One thing that is not in this category right now is anything like a consumer product. So this is the early adopter phase. We don't expect this to be a consumer product yet. Okay, so the upgrade package, just to sort of give you an idea of what that encompasses, and again, this is sort of our first foray into actually making this a product. We've done this with other devices before, but with the Oculus, it exists as an aftermarket retrofit. So somebody sends us their Oculus, we incorporate the eye tracking device into it. So it comes with a binocular 60-hertz slip compensated parallax corrected eye tracking system, very similar to the one I just had it on, but integrated in the device itself. It then will, via C or C++ SDK, give you information about where they're looking, plus pupil size, eyeball position, vector in space, all these sort of technical terms in terms of understanding the rotation of the eyes and things like that. That's all included also. And then at the moment, we have integration for WorldViz and Unity engines. So you can incorporate that data stream directly into the visual paradigm, if you like. And our demonstration, which we'll have set up afterwards, shows you exactly that. So it'll show you where you're looking in your own 3D space as a demonstration that you can interact with boxes and things like that. You'll see. It's probably important to note, for those of you who are familiar with eye tracking, this is not a turnkey system. So this doesn't come with stimulus presentation or data analysis or anything like that. This is a development platform. So it comes with an SDK and the hardware. Without programming this is nothing, right? So we sort of see this even on the research side and the academic research side. We see it as a platform for development of your own software to basically make use of the data and record the data and all that stuff. Okay, so just a little bit more about the way the hardware works. There's no modification of the optical system on the Oculus at all. So there's no degrading of the lenses. The lenses are exactly unadulterated. There's no change to the visual system. We do change the lens holders. You see here, this is infrared illumination built into the system itself. So there's multiple sources per eye. There are cameras integrated into there as well, but you'd never know it. So there's no change to the optical path. It took us quite a while to contend with the extreme eye angle on the camera and the distortion caused by the lens, but that's solved now. The system is as accurate as our normal device. It also doesn't require any change to the power system. The eye tracker is powered directly from the Oculus, so it has its single USB port and its HDMI cable, and that's it. It doesn't physically look any different other than those little notches in the lens holders. And then in terms of the specs, I don't want to get into this stuff too much, but we have a brochure which actually has a slightly more up-to-date list of these specifications and goes into a little bit more detail. Suffice it to say that it's a next generation eye tracker. The eye tracker is not compromised in the least. It's actually on par with our glasses system, which is pretty much the market leader in the sort of real world stuff, just integrated in the Oculus device. So the amount of data that you get, the way the SDK works and all that stuff is similar to any research grade eye tracker. Okay. So that's the presentation I have. The demonstration, we have a system set up with software running. So after afterwards, I just invite you all to come in and see how it works. You can view your own gaze data. There's a little mini game where you can shoot at barrels and things like that. Okay? Cool. Thank you.
Hello there.
Hi.
So I was curious, what did you think about tonight's event?
Tonight's event was really exciting to me. It's actually the first the first meetup I've ever attended at MIT. So I'm new to town. I just moved here from Gainesville, Florida. So just being at MIT is exciting in and of itself. And I'm very, very interested in virtual reality ever since I loved Star Trek.
Yes,
I'm
yes.
actually rewatching Star Trek: The Next Generation right now on Netflix, and I see all the holodecks, and I'm like, all right, I'm ready for holodecks to be in the real world.
Yes,
I want to figure out the people who want to make the holodecks in the real world. And also the eye tracking device I thought was interesting because of the scientific elements of that, and taking people who maybe do have like vision impairments and letting them actually experience virtual reality how everyone else experiences virtual reality. And then just the excitement of virtual reality. As I said, I'm ready for the holodecks. I'm ready to be, I'm ready to be in the Bahamas right now.
Oh, come on, with all the snow we've had here in Boston.
Yeah.
Without a doubt.
Yeah, I moved here from Florida a few weeks ago, so needless to say, it's been like, okay, let's like virtual reality myself, like back to a beach or somewhere. But yeah, no, it's been exciting being here at MIT, and yeah, I'm glad I finally came to the meetup group and to MIT.
Cool. And do you want to share with us your name?
My name's Lindell Brown.
Perfect. Thank you so much for talking to us, and we're happy that you're part of the Boston Virtual Reality Group.
Yes, me too.
All right. Thank you. Bye-bye.